I'm Andrew Ford. This is Dylan Russick and Alex Millman. We built the real-time LED piano teacher. The purpose of this project was to create a product that made it easier for people to learn piano. One of the biggest obstacles when you learn piano is learning to read sheet music. This completely eliminates the need for that. What it does is it takes in video from, this is a live video from YouTube, and playing into our device and displaying which keys you should play on the piano. So it's an affordable way for anybody to learn piano with no experience whatsoever.
So one of the main issues that we ran into was the issue of harmonics, pictured here on the left side of the poster. And what this is it's a frequency response of hitting the C4 key on the piano. And you can see the magnitude or height of the C4 note is the highest, but the second highest is G5. Even though G5 isn't being played, it is one of the harmonics of C4. So let's just say for simplicity, C4 is 200 hertz. There's going to be harmonics at 400, 600, and so on, and G5 happens to be at one of those harmonics. And so that caused a lot of problems with analyzing the frequencies coming in from the phone. One of the other issues that we dealt with was the issue of sampling delay. And so you want more samples because it increases the quality of the signal, but it also slows down the processing speed.
So the way that we approached the project was taking an incoming audio signal from YouTube videos or GarageBand or any other MIDI file player. We took that signal, amplified it, and shifted it up so that it could be read by an analog to digital converter. That was passed through a fast Fourier transform on a microcontroller, where we sent it through the AI neural network, and then you can see the outputs on the LEDs, which tell you which keys to play.
For the electrical hardware for this project, shown here in the top right, we have the schematic, and all this is actually housed in this little white box on top of the LEDs here. So for the electrical hardware, all we have is an audio input signal coming through a 3.5mm headphone jack breakout board. That's passed into a common emitter amplifier, like Andy had mentioned, to give us amplification and DC shift on that signal. That goes directly into the analog digital converter, and that information is passed into the microcontroller. And then on the microcontroller is where we'll be doing the fast Fourier transform and all of the neural network processing. And then also from the microcontroller, we'll be driving all of the LEDs. One of our goals was to create a cost-effective solution. And we can see here our total was under $30. We have the microcontroller, which was the ESP32, which came in at around $11. The 3.5mm breakout board, which was 39 cents. Various circuit components, which came out to $2.32. Some filament, which was approximately $4.50. The LED strip, which was under $9. And the proto board to smash everything together came out to 33 cents. So some future opportunities we had talked about was increasing the clock speed and the memory of our project will allow us to increase our performance. Smaller profile parts will allow this project to be smaller and more portable, allowing the user to have a heads up like you would see in Guitar Hero or some other games to help the user sort of learn how to anticipate notes coming up, and also to create an accompanying app containing like best videos people have created or other videos people are using to learn a song you want to learn, and possibly a sheet music converter which is able to read sheet music directly and create a file for our LEDs. The real-time LED piano teacher is a cost-effective solution which eliminates the need to learn how to read sheet music and pay for an expensive piano teacher, and accomplishes effectively the same thing.